Okay, in this presentation we're going to look at regular graphs. Now we have a very quick exercise here. The question asks us, draw three regular graphs with 8 vertices on each graph. Now, you probably might not have come across this yet, but we have to have non-isomorphic graphs, which is to say that they're structurally different from one another. Okay? So let's start off here. Now I've actually just sort of started out. I filled one in already. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've done a sort of perimeter there. And I've already filled in a couple of the edges here. So vertex 1 has 3 edges connected to it already, so that has degree 3. Okay. Likewise 2, 5, and 6. So they have degrees 3 each. The rest of them have 2. Okay. 3, 4, 7, and 8 right now they have degree 2 because there's 2 edges connected to them. So what I'm going to do here is I'm going to connect 8, 3, and 7 to 4. Okay, so now they all have degree 3. Okay, in each of them. So we have a 3 regular graph there with 8 vertices. So that's the first one done. Okay, now the thing about this is we actually have to do something different the next time. Okay. So we have to sort of not copy this, basically, or not have it structurally similar. Okay, so we have to think about what we can do different for the next one. So let's go back here. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now again, I sort of started have the graph mostly started, but it's just a sort of matter of doing something different at the end. Okay, in this instance with the first example I just connected 8 to 3 and 7 to 4, but I have to do something different this time. So what I could do is I could connect 8 to 2 and that won't work, and I can connect 8 to 3. That won't, well, that's actually just what we've done before, so I have to do something different. So the only really other possible case I can do, if I can't connect it to 5, 6, or 1, basically because it ruins the degree sequence. So it's the only thing I can really do is connect it to 4, and likewise connect 7 to 3. Okay. Now this is essentially a different structure. So it's not isomorphic. So it has a different structure there, if you get me, as opposed to the first one. Basically, just a slight difference at the end. And if you can detect that difference, great. So, one clue about how you might sort of detect that difference is to do a path using that edge there, and see how many nodes you would pass on that path. Okay, that will be different from this here. Okay, and the other case there would be a path of 4 edges here, and in this one 5 edges, just to sort of emphasize that they are structurally different. Okay, actually, I'm sort of getting a little bit ahead of that. Really, I'm going into isomorphism here, but really, it's a sort of key component of this question, just to do something different in both graphs. All right, okay, we'll leave it there.